Alright, so we started our whole chapter. We are on chapter 6, Scatterplots. Learning goal, I can use scatterplots to describe patterns of relationship between two quantities. And specifically today, your goal is that you can create a scatterplot. You know what? Don't be playing around.
Oh, I'm not.
You were though. Don't try and deny. Just look and be on task. So, what we are looking at is, what is a scatterplot? None of it. Focusing with us, please. A scatterplot is a graph that shows the relationship between two sets of data, and the two sets of data are graphed as ordered pairs in the coordinate plane. If you guys look, like I said, when you open up your first flap, there was 4 different graphs underneath. Those are all scatterplots that are listed. We notice that all those dots, they're not in a straight line. They're scattered. They're all over the place. Each one of those dots are from a ordered pair. This dot that was here was put there for a reason, based off its x and y coordinate. Okay? The two sets of data is whatever we are comparing. We are going to work on this today. So turn your page in your foldable to the one that says Graphing Scatterplots. And you should see what I'm saying. Steps to make a scatterplot. We did the very first part, but I'm going to review it again just to make sure we're all on the same page. So, determine the scale for the x and y axis, title the graph and label the axis, and use ordered pairs, the x and y, to plot the data. We are going to do those 3 steps today. Those are the 3 steps you will do for your homework. We're going to do it together right now in class to make sure you know how to. So, step 1, determining the scale. Yesterday we said, here's our data. It's in a table. Our 2 sets of data that we are comparing are absences and our final grade. Okay? That's our 2 sets of data. Our absence are going to be our x coordinate, and our final grade is our y coordinate. When you read your steps, it says, determine the scale. Remember, scale is telling us about how much we're skipping on each line. So, to find the range, we're going to look at our x. This, I'll erase this in a second, this is our x-axis. So I'm going to do that one first. If I look at my absences, we said our high score is what? Nope, on our absences. 10. So I'm going to go right here and say, okay, this is my high. What's my low? 0. Okay, so we have to find the range. Range of data is always your biggest number minus your smallest number from your data. So 10 minus 0 is 10. Our range has to be 10. If I look and I have 12 lines, if I have more lines than I need, I'm just going to go ahead and say, hey, I'm just going to make them all 1, because 10 is really close to 12. So right here, this is your origin. That will always be 0. When we go to do our graphs and we go to do our coordinate points on here, that's our 0. Remember, this graph is really like our ones we've been doing, but we're staying in quadrant 1 right now. So we'll have 0. And I'm going to go ahead and label these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so I have those labeled. That's my x-axis. Now we have to do it for our y-axis. We have 12 going up on the y-axis, but what is my high score for my y-axis? 95. Okay, so that's high. What's my low? 65. And I think this is almost where we left off yesterday. So I'm going to show my work. 95 minus 65 is 30. So we found our range to be 30. That's where we stopped yesterday, right? Okay. Now, if my range is 30, I want to take my range, 30, and we are going to divide it by how many lines that we have to graph on. And we have 12. And so if I did 30 divided by 12, we would get, you get 2.5. I've already done the math. So 30 divided by 12 is 2.5. That tells me my scale, the space between each line, I'm going to go up by 2.5. But here's the nice thing. I don't have to use it. This is telling me my minimum. That's my minimum scale. Me personally, I don't mind counting at 2.5. I think it's kind of easy. 2.5, 5, 7.5, 10, 12.5, 15, 17.5, 20. But some of us don't want to do that. So I can change my scale and I can round it up. I cannot go down. Why do you think I can't go down? What would happen if I go, let's just go down to 2? What would happen if I took my scale and I rounded down to 2? Any ideas what would happen? Negative. It wouldn't be a negative. The reason my scale is a minimum, look, we took our range and we divided it. If I went by 2s, I wouldn't reach my highest number of 95. I won't be able to reach it. If I go by 2.5s, I will. So I can only either use the minimum or round up. I don't think we're going to use 2.5. Instead, let's take our scale and we'll make it, we'll round up to a whole number. We'll make it 3. Okay? You're going to have to do this then, so make sure you're following. We found our range. We divided it by how many little lines we had. And that gave us our minimum scale. And then I rounded up to the nearest whole number, or easy number to do. Now, there's one thing we're going to change. Divide by the number of lines on the axis. Start at the origin. If you have a big jump from 0 to the smallest data point. Our smallest data point was 65. If I'm counting by 3s, is that a big jump from 0 to 65? Yes. Do I really want to sit there on a graph going 3, 6, 9, 12, 15, 18 when I know I'm not using that part? So this is what you do. This first line is your smallest data point. It is 65, right? That first line is going to be your smallest data point. But if I leave it like this right now, and I say 0, 65, me as a mathematician, I look at your graph, what do I think your scale is?
65.
I think your scale is 65. You went from 0 to 65. I think every line will jump by 65. To show that that's not our scale yet, you just do this. You do a little squiggly line in between your 0 and your 65. That tells me as a mathematician, hey, they compressed this data. They took it, there's missing stuff there, they're not using it, so they just brought everything and squished it down so I can see all my graph. Now, I'm going to go ahead and I'm going to use my scale of 3, and we're going to go up by 3. So 65, 68, 71, 74, 77, 80, 83, 86, 89, 92, 95, 98. Gentlemen, are you doing this on yours? Okay. Now if you look at what we've just done, my numbers went from 0 and I went up to 98. Will that cover my highest score?
Yes.
The highest score is 95. We've covered that. You have to do this today by yourself, so I want to make sure we understood all those things that we did. If you're ever confused, make sure you go right here. We just did these steps. So if you get confused on today's homework, just go ahead and do this. Follow each step. We found first our high and low. You subtract and find your range. Divide your range by how many spots you have. That gives you your minimum scale. We rounded it up to the next whole number. And then we went 0 and we put our lowest score and did a squiggly line and then just counted up. Okay. We've labeled, we've done it for the y-axis. Step 2, title the graph and label the axis. Okay. What should we title our graph? What do we graph? Sure. We have lots of options what we can do, but I'm going to at least have a title. I'm going to say absences. I'm going to say versus final grades. This is going to be one that you don't have a set right or wrong answer. As long as you title and it's relevant, you'll get credit. You could have just said your title was final grades. You could have said, my title was absences affecting final grades. Final grade versus absences. You could have switched them around. It's okay, but you have to tell us, when we as mathematicians look at your graph, what is it telling us? The other part of step 2 is label the axis. Well, holy cow, that's so easy because x-axis is what? So I just take that and write it here. What was our y-axis? Final grade. Okay, step 2's done. We've done step 1. We've done step 2. And you're only doing 3 steps today. The next step is use ordered pairs X and Y to plot the data. This is how we're going to do it. Here's my X, here's my Y. So this says 0, 95. So I'm going to go at 0 up to 95. And I put there. Here's a trick what I do to help me so I make sure I get them all. Once I'm done with one, I just kind of put a check on it. The next one is 3 and 88. I'm going to go over 3 up to, there's 86, 89. 88 has to be right about here. Okay? I have to do 290. 2 up to 90. And so on. Go ahead and finish. I'm going to pause our video. I want you to go ahead and finish putting all those coordinate points on. Okay? I'm going to pause our video, and then we'll compare and see, do we have the same looking scatter plot? All right, so we look at this. Yours should look something like mine. It actually looks pretty close to almost a linear line, doesn't it? Like, it's almost a straight line. It's not, but it's close. This is what our scatter plot is. I'm going to change colors real quick just to show you what could happen and how we could have other things. Absences, I could have had someone that only had 2 absences. They would have gone twice, but they had a score of like 74. Is that a possibility? It's really a possibility. Could I have someone that's gone 9 times, but they still score a 95? Yeah. There's always certain circumstances that are going to happen that are going to change the data. This is not set in stone. This is not going to say, Kate, if you missed 5, you definitely have this score. No. But what we are going to see, and we're not going to do it today, but in the near future, do you think I could look at this data and say, hey, Kate's going to miss, she missed 5 days of school. She skipped my class 5 times. Can I guess what she might get on her test? 0. No, I don't think she's going to get 0, but would I be able to look at this and make a guess?
83.
Why would you say 83?
Because she did this like every single day, but she still doesn't know.
But why 83 did you guess?
That's on the board.
Yeah, this is what we end up using scatter plots. This is in a couple days. But if I say 5, and I come up, and it's in this little area, I would say, hey, I think she's going to score somewhere in here. I would expect her, if she skipped 5 days class, that she's still going to score somewhere between 80 to 86 on the test. Maybe she does, maybe she doesn't. But that would be guessing. That would be my prediction. All right. That is your assignment for today. You're going to have to do this 3 times today. But this is all you have to do. For today, your goal is I can make a scatter plot. You can use your book. You are going to do numbers 1 through 3 steps. I really want you guys to slow down. Step 2 and 3 are simple. Step 1 is the most difficult for today. Determining the scale. So let's talk about it real quick and then I'll give you work time. How did we find the scale? How do I find the scale for my y-axis? How did I find out what numbers to put down?
Because there's a chart.
Well, there's a chart, but...
The highest one is
Okay, there we go. We start with what, Sydney? You look at your highest score, and you subtract your lowest. You find your range. High versus low. That gives me my range of 30 so far. What did I do once I found my range? What do we do once we find our range? Hey, put the chair down. Please focus. Pay attention. Okay, what do we do after we find our range? This is what you have to do in your homework 3 times. Huh? No, not yet. To figure out what this is. Let's subtract it. Look at here. Divide by what? By the number of lines that we have available. So you're going to look at your graph and you're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I had 12 possible lines. My range was 30. My high was 95. My low was 65. My range was 30. So you'll do 30 divided by 12. That's where we got 2.5. I can either make my scale go up by 2.5, or I could round that number up to an even number, which we did to 3. Then the last thing we did was we start at 0, always start at 0. And since there's a big jump to 65, we just did squiggly, set our lowest number, then they went up by 3s. So I think this is going to work best when you guys start doing it by yourself and I can answer questions as you work. So, your assignment, if you go to your homework, turn to the part that says homework. Use, we don't want to do that part yet. Where is it? Oh, it's underneath. I thought mine different. Okay, it says day 1 homework. Now, do you see how it also says day 2, day 3, day 4? That's because this graph that we're about to do will be used multiple times. So you better be using a pencil in case you make mistakes. You have 3 sets of data. On number 1, age and data used. We're talking about cell phone. Number 2, fat in grams. So we're talking about on something how many grams it has and how many fat grams it has. There's your graph. here, high school and college. So you need to do those 3 by Monday. Your homework says graph the scatterplots. By Monday, you need to have these 3 graphed just like we did on our example. Sydney? Yes.
So for the scale, we've actually put outcomes on.
Alright, go ahead. You have the rest of the class to work.